Hi, this is the last video in Chapter 6 in Geometry. This is section 6.6. We're going to talk about coordinate geometry of quadrilaterals. We're going to put quadrilaterals in a coordinate plane. We're going to give ordered pairs for its vertices, and we're going to try to figure out, well, what kind of quadrilateral is this? Is it a parallelogram? Is it a rectangle? Is it a rhombus? Is it a kite? What is it? By looking at it on a graph. And we're also going to put some quadrilaterals on a graph and say, okay, where should this point be? If this is going to be a rhombus, where should this angle be? Where would this point be? So we're going to do that, and we're even going to look at how to take quadrilaterals with no numbers, just variables. It's almost like creating our own formulas to show the relationships in quadrilaterals. That's kind of interesting. So put on your seatbelts and let's get started with this last section. Okay, I have put a quadrilateral on a graph, labeled it A, B, C, D. A is at -1, 3, B is at 3, 2, C is at 4, -2, D is at 0, -1, and my task is to classify this quadrilateral as specifically as possible. I'm going to show you two ways to do that. And the thing that we need handy and need to remember how to do is how to find the lengths of the sides. So we need the distance formula. How to find the slope of the sides so we can tell if they're parallel or not. So slope formula, and also midpoint. What's the midpoint of the sides? That's also important because we may be checking diagonals. Do they bisect in the middle? That kind of thing. So those three formulas need to be handy. You need to be able to use them. So let's look at this one, and let's just look at the four sides. Let's check their lengths and their slopes, and then compare opposite sides to see, are they the same length and are they the same slope? Let's start with this segment here at the top, A to B, and let's just find the slope of that segment. Since it's on a graph and everything's numbered by ones, I can count squares, which is a little easier than using the formula. So to go from B to A, I would go up, my rise is 1, and I'd go to the left, 1, 2, 3, 4. So my slope is 1 over -4, or -1/4. So I found its slope, I notated it here. Now I'm just going to go ahead and find the length as well. Why not, since I'm working on this segment? How long is it? So remember, it is the square root of the difference between my x's, the difference between -1 and +3. So 3 minus a -1 would be 4. So that's 4 squared, plus the difference between my y's, which is 3 and 2. 3 minus 2 is 1. So that's 1 squared. So that's 16 plus 1. Well, that's the square root of 17. I don't need to put that in my calculator. I just know its distance, its length, is the square root of 17. So I'm going to note that as well. Now I'm going to do the same process with this side, BC. I'm going to find its slope, and then I'm going to find its length. So the slope from B to C, my rise is 1, 2, 3, 4 over -1. So it is -4 over 1. So my slope is -4. So I've notated its slope. Now I'm going to find its length. So I need the square root of the difference between my x's, which is 3 and 4. The difference between 4 and 3 is just 1. 4 minus 3 is 1. So it's 1 squared plus the difference between my y's. So that's 2 and -2. 2 minus a -2 would be 4. So that's 4 squared. Well, that looks like the square root of 17 as well. Let's do the same process with CD. So for the slope from C to D, I'd go up 1 and to the left 4. So that's -1 1 over 4 is its slope, and its length is the difference between my x's. 4 minus 0 is 4. 4 squared plus the difference between my y's, negative 2 and negative 1. It's a difference of 1. 1 squared. Again, we have the distance is the square root of 17. At this point, you guys, you could have stopped a while ago and figured this out. I'm showing you, if you don't remember the characteristics and the qualities of these different quadrilaterals, then you have to do this for all 4 sides. But if you remember how to show what a figure is, you could stop at any moment. But I'm going to go ahead and do the 4th side anyway, just to show you. Okay, the last side is AD. To go from A to D, my rise is 4, and my run is negative 1, so my slope is negative 4 over 1. The distance is, the difference between my x's is 1 squared, plus the difference between my y's is 4. Ah, this is looking familiar. It is also the square root of 17. Now, what do you notice? If I look at opposite sides, like AB and CD, their slopes are the same. Also, BC and AD, their slopes are the same. Opposite sides are parallel. So, it's a parallelogram. Also, all 4 sides are the exact same length. So, if I write parallelogram, I'm not correct. It's a parallelogram where all 4 sides are the same. This is a rhombus. Okay, we just analyzed this quadrilateral by looking at all 4 sides, checking their slopes and checking their lengths and then comparing them, and we figured out by doing that this was a rhombus. There are other ways to determine what kind of quadrilateral this is, and that's by looking at the diagonals. Because remember, if it's a parallelogram, if it's a parallelogram, the diagonals will bisect each other. So that will tell you a lot. So let's look at the diagonals AC and BD, and let's find their midpoints and see if their midpoints match. If they do, then I know the diagonals bisect each other. Okay, let's look at diagonal AC. This is negative 1, 3, and 4, negative 2, and let's use the midpoint formula to find where the middle of this diagonal is. So the midpoint between negative 1 and 4, I'm going to add those together. It's 3. So that's 3 over 2. That's my x coordinate, or 1.5, 1.5. Do the same thing with my y's. 3 plus negative 2 is 1. Divide that in half, that's 1/2. So the midpoint of this diagonal is 1.5 and 1/2. I'm going to do the same process with this diagonal BD and see if its midpoint is in the same spot. So the midpoint between, in my x's, 0 and 3, 0 plus 3 is 3, divided by 2, that's 3 over 2. It's looking good so far. Let's do the same process with my y's. I'm going to add negative 1 and 2, that's 1. Divide that in half, that's 1/2. All right, so the midpoint of both diagonals is the same. That means they do bisect each other. That means it's a parallelogram. That's great. So now we know it's a parallelogram. We just don't know what type. So we can compare the slopes of the diagonals as well. Because if the slopes are not perpendicular, then it's just a parallelogram. But if they are perpendicular, then it's a rhombus. So let's look at the slope of AC. The slope of AC from A to C is 3 minus negative 2, 3 minus negative 2 over negative 1 minus 4. So that would be 5 over negative 5, or negative 1. That slope is negative 1. Let's look at the slope of BD. So it's y minus y, 2 minus negative 1 over x minus x, 3 minus 0. It's 3 over 3. It's positive 1. Negative 1 and positive 1 are opposite reciprocals. If I multiply negative 1 times 1, my answer will be negative 1. These two diagonals are perpendicular. That means it's a rhombus. This is why knowing the characteristics of the different parallelograms will help you when you try to do this. So we found that it's a rhombus without having to do quite as much as we did by looking at all the sides. One thing we didn't check though is it a square? We can tell by looking that it's not a square, but if we wanted to know for sure, because sometimes it can be a little tricky, the diagonals of a rhombus are perpendicular, so are the diagonals of a square. But if it's a rhombus, the diagonals are not the same length. So using the distance formula of AC and the distance formula for BD, I can tell that they're different lengths, then I know it's a rhombus, not a square. So I can do all three formulas to the diagonals and tell everything about my quadrilateral. Okay, here's a different type of problem. I'm told I have a parallelogram EFGH. E is here at 0, 0, and H is at 4, 1. Where is F and where is G located if the diagonals intersect each other at point T, which is 3, 2? So their point of intersection is 3, 2. How do I find the other two coordinates? In order to find them, remember that the diagonals of a parallelogram bisect each other. That means that point 3, 2 is going to be the midpoint. So I need, if I start here and I want to go over here to G, one end point is 0, 0. I need the other end point G, but I know the midpoint is 3, 2. So let's use that mental shortcut that I showed you. If I have one end point and a midpoint, how do I find the other end? So I'm going to write this down. Okay, I'm starting at E. I'm heading towards G. Halfway there, I've reached T. So along the x-axis, to go from 0 to 3, I did what? I added 3. So add 3 again, and I would end up at 6. For the y's, to go from 0 to 2, I added 2. Add 2 again. 2 plus 2 is 4. So G should be at 6, 4. Now check yourself. Would 3, 2 be the midpoint between these two? And it would be. So we found G. G is at 6, 4. Okay, let's repeat that process. On the other side, I'm starting at H, and I want to figure out where F is on the other side. H is at 4, 1. That's one endpoint. When I'm halfway there, I'm at that midpoint, that point of intersection, 3, 2. So where would F be on the other side? So let's do the x's. So we go from 4 to 3. I subtracted 1, so subtract 1 again. 3 minus 1 would be 2. And when I do my y's, to go from 1 to 2, I added 1. Add 1 again. 2 plus 1 is 3. Now double check. Is 3 between 4 and 2? And is 2 between 1 and 3? Yes. So F should be at 2, 3. So I connected them with a line, and it looks like a great parallelogram. This problem was made a little bit easier because we had that one vertex at 0, 0. So what we're going to do now is I'm going to place different quadrilaterals on a coordinate plane, and I'm going to use that 0, 0 to help me. And we're going to look at coordinates for the vertices without numbers, just with letters. The advantage to doing that is you're looking at relationships between different points and different figures, that will be true no matter what the number is. If you can show it's always true with the letter, then no matter what number I replace that letter with, it will still consistently work. That's how formulas work. So let's look at that next. Here is a rhombus that I've roughly sketched on a coordinate plane. No numbers, just letters. I'm given that L, its coordinate is W0. This is, I'm told it's a rhombus, JKLM. This is definitely 0, 0, and the only thing I know about this rhombus is that the lengths of the diagonals, one has a length of 2W, and the other has a length of 2T. I put 0, 0 right in the middle. Okay, since I know that one diagonal has a length of 2W, I'm going to look at this here. This 0 cuts it in half, and this length here, because it's my x length, from 0 to L is 1W. I need the whole diagonal to be 2W. So if I have 1W on this side, I'm going to need the other W on this side. So from 0, I'm going to go a length of W to the left. So that distance is going to be negative W, right? Whatever this length is, this is going to match it. So that's negative W. And I'm not going up or down at all. I'm still on the x-axis. So my y-coordinate is 0, and that's the coordinate of J. See how this works? My other diagonal has a length of 2T. It's cut right in the middle at 0, 0. So I'm going to put one of my T's above and one of my T's below. So I'm going to go a length from 0 up a distance of T. Left to right is still 0. So this point would be 0, T. Then from here, I'm going to go the other direction, the other T, so that the length will be 2 T's. I'm going down, though, in a negative direction. So starting at 0, I'm going to go not left to right at all. My x-coordinate is 0, but I'm going down a length of T. And there's my coordinates for M. That's how you do this using letters. Okay, my next one, an isosceles trapezoid. This time, instead of putting the 0 in the middle, I put this left edge at 0, 0, and a couple of my points are given. So this point, P, this is OPQR, this trapezoid. P is at point PH, so I'm given that. And R is at R0. This is obviously 0, 0. This is the only point I need to find. What would Q be? And this is tricky. Trapezoids and sometimes parallelograms, when they come at a slant, that can make listing these points a little trickier. So I want to show you, remember, think in terms of X is my distance left to horizontally, Y's are my distances vertically. So if we notice, that means this P is the distance from here to here. That's what that means. And this H is, well, that corresponds to the height of my trapezoid, doesn't it? So this P is this distance, and H is that distance right there. Since it's an isosceles trapezoid, I can draw another one on this side. That means this distance here would also have to be P, wouldn't it? And this would also still have to be H. So I know my height, I know my Y has to be H. What is my X? So sometimes some of these you have to add or subtract. This point here, R, is an X value of R. So if you start from that and you go back here, you're going to take this R value and you're going to go back this P value, so you're going to subtract P. So this actually ends up being R minus P. R minus P. So I showed that to you. Hopefully it makes sense you've seen it. Coming up with it yourself, that can be pretty tricky. Here's another one for practice. I put a parallelogram on a coordinate plane, and I've labeled a couple of its points. Z is C0, W is 0, 0, Y is A plus C, and then B. That's why, from that, what would X be? So, one thing to know is this distance here, I make this triangle here, this triangle would be exactly the same. That means this length and this length are the same. Okay, that kind of helps with a parallelogram. This is at C, this is A plus C. So they took this C and they added A to it. That means this distance here is A. Oh, so what's this distance here? It also has to be A. So my x-coordinate of X is A. Because it's a parallelogram, my Y's will be the same. So the coordinates of X would be A, B, and then everything would fit then. Now, the midpoint. How do I find the midpoint? So I'm going to use the midpoint formula, and I can do either one. I should get the same answer. Let's do this one just because it uses 0, 0, and that's always easier. So I'm adding my x to 0 and dividing in half. So my x is A plus C plus 0 over 2. That's my x-coordinate. My y is B plus 0 over 2. That's my y-coordinate. If I do this, because this was AB, if I do it with these 2 points, I should get the same answer because they bisect each other. That midpoint should be the same. So if I go A plus C divided by 2, there you go. And if I go B plus 0 divided by 2, yes, I get the same thing. So you can have answers that look like this. Okay, there's the last cool feature, cool quality that I want to show you here at the end of this chapter. And that's just a regular quadrilateral. It's not a parallelogram, not a kite, not a trapezoid, nothing special, just a quadrilateral, but it is convex, not concave. So I've got a convex quadrilateral. If I do the medians, or in this case the bimedians, because it's not a triangle, but if I take the midpoint of each side and I connect them, any quadrilateral, they will bisect each other. So let me try to draw that and see how that looks. Okay, so here I visualized approximated where the midpoints would be and connected them, and it does look like they bisect each other, which is pretty neat, but why do we care? Well, I want to show you. If these diagonals bisect each other, then what happens if I connect all those midpoints? So if I connect these two, and these two, and this, what kind of shape have I just created automatically? Because those bimedians bisect each other, those are the diagonals of this quadrilateral. And if the diagonals bisect each other, this has to be a parallelogram. So no matter what type of quadrilateral it is, if you connect the midpoints, you're gonna get a parallelogram, which is pretty cool. In your textbook, they show this with coordinate geometry with letters, and they do all these formulas. And I'm not gonna do that in this video. I'm just telling you how this works to show you it's just another cool, magic trick of math, just another cool property, consistency, and the wonder that you can find as you look at these relationships that God has created in His creation. I just think it's fun. So that concludes this section and this chapter, chapter 6, which all dealt with quadrilaterals I will see you guys next time in chapter 7.